All right, so we are the ShapeCorp team of Advanced Metalworks Enterprise working on extrusion quenching simulation project. Since this is a multifaceted project, we have members coming from three different departments, that being material science and engineering, manufacturing, mechanical engineering technology, and the mechanical engineering department. Going over the project, we were tasked to develop a lab scale equipment to simulate high pressure spray quench system. And the data collected from this model can be used and applied to Shape's production process. We're given a few different parameters to monitor and control, the primary ones being incoming water temperature, quench pressure, nozzle position relative to the part, and being able to run 5 parts sequentially. Design justification for this in-out water flow system is it allows better control over the input water temperature, makes it easier to measure the output water temperature. We can kind of monitor and calculate the reclamation rate of that water and compare that to losses to steam and evaporation. And overall, it's just less complex of a system.
So before we can quench parts, we got to heat them up first. And to do that, we're going to use MTU's gray furnace number 2. And we did 3 temperature uniformity surveys on that using AMS 2750G with a set temperature of 1100 F. The first temperature uniformity survey, we had a working zone of just the dimensions of one part, and that had a temperature uniformity of plus or minus 43 degrees F. And then we did a full furnace temperature uniformity survey that had results of plus or minus 70 F. And then after those 2 temperature uniformity surveys, we discovered that the heating elements on the door weren't working, so that we needed to replace the wiring to the door. And then once that was done, we did another temperature uniformity survey of the full furnace, and we got a uniformity of plus or minus 41 degrees, which gave us a furnace class 6 rating by AMS 2750 standards.
With the furnace all set, the next step was the quench box, which we built out of 8020's T-slot frame aluminum, which mirrors the ShapeCorp's actual production setup using their specific nozzles supplied by Granco Clark. The water is fed through a single manifold system that splits out to all 30 pumps, which are then held in place by 3D printed brackets. We also completed a nozzle functionality test to make sure that the system itself works.
So to make sure our quench box is going to work as designed, we're going to test the quench box by having one of 3 different samples provided to us by ShapeCorp. And then we're going to heat them up in gray furnace number 2, and then quench them out in the quench box. And then for each part, we have them thermocoupled up so that you can read the temperature across the length of the part.
So to help with the quench box, there was a thermal transient heat transfer analysis models to be run for each of the 3 sample parts that were given by Shape. We used a 3 elements to the thickness mesh for each of the parts. Each model is depicting 0 seconds, 5 seconds, and 10 seconds through the cooling process of that analysis. And there's some assumptions of using a 6005 T5 aluminum, stagnant water for film coefficient, which is just used for the analysis of that temperature cooling, a ambient temperature for the solutions, and an initial temperature as well. This one also just depicts, this is the second sample for the that Shape gave us, and this is just showing another analysis, which was also done in ANSYS, and it shows a thermal transient heat transfer analysis of that second part. And then this is the third and final sample part that Shape gave us, and this is also showing us how it cools from 1100 degrees Fahrenheit to the ambient temperature shown in the assumptions. As for the cooling graphs, this is Fahrenheit over seconds, and these are just the graphs of each sample to give a better understanding of how the cooling works when the parts are done.
With the completion of the quench box and ongoing validation testing, we've completed the requirements set by ShapeCorp, and in conjunction with any additional requirements that come up from the sponsor, we've completed their task. And we will continue our data collection and improvements until the end of the semester.